Hello everyone, my name is Vanshaj and I'm going to talk about what an antivirus is, how it works on our machines, and how can we hack or bypass it. We all are familiar with what an antivirus is. Let us quickly revisit the definition. An antivirus is a computer program used to prevent, detect, and remove malware. What exactly is a malware then? As the name suggests, it is any malicious activity that is targeted by an attacker to be executed on a victim's machine to gain illegal access, steal information, disrupt the normal behavior, etc. It can take many forms. It can be a virus, a worm, Trojan, ransomware, spyware, adware. In short, it can badly damage our systems. This is where antivirus comes in and saves our system from all these cruel malware. The question is, how does an antivirus work? There are many different techniques used by antivirus vendors. Let's start with the most basic one, the signature-based detection method. The antivirus installed on the user system has a database of signatures. What are these signatures? A signature is a unique string of bits or a binary pattern of known malicious programs. So whenever a user downloads or tries to access a file, the antivirus will convert the file into hex code and scan it with all the available signatures. It searches for a specific set of commands that may correspond to a potential malware. If the antivirus detects that the file has code matching to any one of the signatures, it then marks the file as a threat. It then removes or quarantines it based on the severity of the malware. This is the reason we get so many updates from an antivirus software. It is the signatures that are being regularly updated and sent to us by the antivirus vendors to help us prevent from the new malicious activities being crafted by attackers. Great! We have the most up-to-date signatures with us and we can tackle any malicious activity. What is the problem then? And how can an attacker bypass or hack an antivirus with all the signatures available? What if we alter some sections of code of a well-known malware? Will this variant of the malware be detected by the antivirus? Well, some antivirus softwares just perform a basic scan of a file with the available signatures, and if they don't find anything in common, they just consider that file to be safe to use. And it is difficult for these softwares to detect any variant of a known malware. So the attackers just tweak or modify some code so that the malware is undetected by all the present signatures. Let us look at some strategies by the attackers. The first one is packers and encryptors. These are tools used to compress and encode binary files. The payload is combined with a legit program and encoded so that it bypasses the signatures. Packers unpack the payload into memory and execute it. This will be our demo. Some other strategies are anti-debugging, which prevents binary from being analyzed in an emulated environment. And another one is obfuscation, which modifies binary files to change signatures, but it preserves functionality. Let us begin our demo. Okay, let's start the demo. So in our demo, we have two users. One is the targeted user, that is the innocent user who is using Windows. And we have an attacker who is using Kali Linux on a virtual machine. And with the help of Metasploit, the attacker is going to attack the user's machine. So the goal of the attacker is to gain illegal access to a user's machine to do things which can harm the user. So we have a folder in the user's machine called my folder underscore nobody can access, and the user believes that nobody can access it. That's why the user has named it in such a way. And this folder contains all the sensitive information that a user has. So to access all these files, the attacker is going to trick the user into downloading an executable which will be infected by malicious code. And as soon as the user starts the installation, the attacker will have access to the user's system. Let's see how it happens. So the user is fond of movies and has found a website where one can download a software that allows for watching any movie on the desktop without the internet. The user, being innocent, downloads it, runs the setup, and waits for a couple of minutes as described by the website. While the user waits, the attacker will run the exploit and affect the user's system. Okay, so let us quickly create a payload, pack it with an executable, and encode it so that when the user downloads it, it will not be detected by the antivirus and will completely bypass it. We will be using MSF Venom to create the payload. The A flag is used to describe the platform, that is Windows in our case. The X flag specifies the executable to be combined with the payload. P stands for the payload which we'll be using and within which we have to describe the host, which is the IP address of the Kali Linux VM instance and one of the available ports. Next, we're going to describe the encoder that we want to use to encode the payload. N specifies the length of the knob sled. I is the number of iterations of encoding the payload. P is the bytes that will be filtered out, and FNO are the output parameters of the file. So the encoded payload combined with the executable will be generated as movieplanet.exe. This might take time, so I will just fast forward the video. Okay, so the file is created and we can also see it in the home directory. Now we will copy this executable in the directory of the website and then update the name of the file to be downloaded to movieplanet.exe so that it gets downloaded whenever the download button is clicked by the user. Next, we will create a listener that will listen to the host and the port that was specified earlier in the payload, and the listener will get a notification whenever a user opens the executable. Now we will run the listener. Now we navigate to the role of the user and download the file. You can see that the file downloaded without any warning or threat, indicating that it was not detected by the antivirus. But the user thinks that another check would not do any harm and runs it against a quick scan with the antivirus on the machine. Oh, as you can see, no threats. The payload indeed has bypassed the antivirus. Since it is a variant, therefore it was undetected. The user is confident after the scans and considers the file to be safe and runs the executable. As directed, the user is asked to wait, and the attacker will now do the exploit. Back on the attacker's end, we get a notification that the user executed the payload. It says a session was open. Let's check the active sessions. Oh, great. We see the user's machine name in the active session. Let us now quickly interact with it and go to the directory where the secure folder is. Okay. Okay, we can see that we have found the secure folder. Let's quickly navigate in the folder. Okay, we have all the sensitive files that we were looking for. Let's look at the sensitive details in the bank, like the bank details. So we see all the bank details. We also see the password for different accounts of the user. Great. That's great. Let's delete all of them. Also, the waiting time must be over for the user, and let's just quickly summarize them after the deletion and check out the reaction of the user. That's true. The user has been hacked. The user is shocked and runs to the secure folder, and as we all know that what happened, all the files are deleted. Let us see why this happened. We use VirusTotal, which tells which antiviruses identify a file as threat. We upload our file and check. We see that only 29 out of 67 detected it as a malware because the code was altered and did not match the signatures of many antiviruses. We see Quick Heal is on the list and it did not detect the malware, and this is the antivirus which is installed on the user's system. And this is the reason why the attacker could easily exploit the user system. As you could see in the demo, that 38 out of 67 antivirus softwares could not detect the malware. So what did the other 29 softwares do? Let us talk about some of the strategies used by the antivirus vendors to defend such attacks. The first one is the anomaly-based detection, which checks the running program for patterns of behavior and identifies what the program will execute. If it tries to change OS files, network settings, or perform any other such malicious activity, then it marks it as a threat and takes requisite actions. The other approaches are data mining and machine learning. Antivirus vendors are putting great efforts to build ML models that can learn the behavior and patterns of program features. Another approach is download reputation, which allows for a check to be performed against files as they are downloaded. It is basically a file checksum lookup, and the checksum is matched against known files and reputations. In the end, I would like to say that antivirus software with merely just a signature-based detection have become dead and obsolete with increasing zero-day vulnerabilities. These are software or hardware flaws that are unknown to the manufacturer or vendors, and until the vulnerability is detected by them, the attacker already has full access over the system. These attacks cannot be prevented just by conventional antivirus softwares, and more robust strategies need to be implemented, like sandboxing that checks for the behavior in a virtual environment. This makes it extremely hard for the attackers as the payload never gets executed in memory. Also, instead of blacklisting a software, there should be an implementation that whitelists a software, allowing only safe to use applications. Thank you for being such a great audience. I would love to answer any questions.